So today we're going to talk about acidosis and alkalosis and the carbonic acid bicarbonate buffer system. There's two types of acidosis and alkalosis. There is respiratory and metabolic. And each one of these has both an acidosis and alkalosis state of being. So there's respiratory acidosis, respiratory alkalosis, and there's metabolic acidosis and metabolic alkalosis. Now, the important thing about this is what we're going to go over, the carbonic acid bicarbonate buffer system. Now, you might have heard of this called the bicarb buffer system, but it's the same thing. The full name of it is the carbonic acid bicarbonate buffer system. Now here is the formula up here, the chemical formula up here. This is the carbonic acid bicarbonate buffer system. And these arrows back and forth means that this stuff can go back and forth. This can go, either these can equal this, which equals this, or it can go backwards. You can have this down here and it can go back up and turn back up into carbonic acid, and then that can go back up and turn back up into water and carbon dioxide. So just these arrows that go either way mean that the formula can go either way. Things break down, put back, reassemble back together, and break down again in both ways. This whole buffer system keeps the body in equilibrium. That's the normal state that the body is in, because we know the pH of blood is about 7.35, and so you can't really get, if your blood pH levels get too high above 7.35 or too low below 7.35, you can die. So we want to make sure that this stays about the same, and this bicarbonate buffer system is what does that, is what keeps it in equilibrium. Now in the field, like if you're a nurse or a healthcare practitioner, you're given the patient's readings, you're given their pH, they take a blood sample, and you're given the patient's pH, you're given the patient's CO2 levels, and you're given the patient's HCO3 levels. And this is the bicarb. And this is obviously carbon dioxide, and then pH. So what you're looking for is you're looking for an acid-base imbalance. So just to look at this bicarbonate buffer system real quick, this chemical equation, because not everybody is, likes a lot of chemistry, so I want to explain this real simply. If you look at this, you're going to have to memorize this, but it works itself out with just simple addition and subtraction if you look at it. Here's an H2 right here. Here's an O. Here's a C. And here's an O2. Now, when these all combine, going this way, the H2 comes over, and here's H2 right here. The C, here's the 1C. The C comes over and is right here, and then these oxygens combine. Here's one O, and here's two O's, two oxygens. They combine and turn into O3. So see, nothing's lost and nothing's gained. They just shuffle around until they make a new product, this carbonic acid. Now likewise, from the carbonic acid over here to the bicarb and hydrogen ions, you have, here's the lonely C right here, one individual C, and it comes over and it's one individual C right over here. Here's the O3, and the O3 travels with the C, it comes over, and it's still part of that bicarb. Here's the O3. But here's two H's. And what happens is the two H's split. One H goes this way, one H goes over here. And this H that comes over here loses an electron. It leaves the electron behind. So it turns into an H positive, a positive hydrogen ion. This H over here takes the electron with it, and so that's what makes this bicarbonate negative right here. So see, it's all math, it's all just addition and subtraction. There's nothing lost, nothing gained. It's just that these elements reshuffle and turn into two different products over here. It's just about reshuffling the exact same elements. So the same elements are in this, the same elements are in this, and the same elements are in this. They're just reshuffled together to make different products. Now let's go over respiratory first. Respiratory acidosis and alkalosis. Now with respiratory, you're going to think lungs. And when you think lungs, you're going to think CO2 levels. The cause of respiratory acidosis or alkalosis is always a flux in CO2 levels. Now here for metabolic acidosis or alkalosis, the cause is always a flux in bicarb or hydrogen levels. So when you think metabolic, I want you to think kidneys, and that is the renal system. That is always controlled by the balance between bicarb and hydrogen ions. Now, respiratory acidosis and alkalosis, as I said, the cause is always a flux in CO2 levels. So what happens is, say you can't breathe right. You have some sort of a respiratory infection, or there's some sort of alveoli damage in your lungs, and you can't breathe out. If you can't breathe out, you're not getting out your CO2, because the whole purpose of breathing is to rid yourself of the extra CO2 buildup, the extra carbon dioxide buildup in your system. So if you can't breathe out, that CO2 level rises because you're not getting rid of it like you should. Then your hydrogen ions are going to rise. What do we know about hydrogen? A positive hydrogen ion means acid. Anytime you hear the word acid, think of a hydrogen ion. Hydrogen ions are acidic, so a buildup of hydrogen ion means you're increasing the acid. Now, down here, if you are breathing out too much, you're getting rid of too much CO2 out of your system. And up here, when you can't breathe out, you're not breathing enough, you're not breathing out enough, this is called hypoventilation. Hypo meaning under the amount or too low. So too little ventilation, hypo. But down here, it's going on if you're breathing out too much CO2 out of your system. Well, that is hyperventilation. And hyper just means too much. Just like if you're hyperactive, you're too jittery, you have too much activity, you have too much energy, hyperactive. So hyperventilation, you're breathing too much. And I think we all know what hyperventilation is, when you're going back and forth breathing too much for some reason. And that's when you start to get dizzy. It's because you're getting rid of too much carbon dioxide. So back up here, up to the formula, hyperventilation, you breathe out too much carbon dioxide, and that makes your hydrogen ions go down. So up here on the top, if your hydrogen ions go up too high, that would be acidic. And down here, if your hydrogen ions go too low, that would be alkaline. Metabolic, acidosis, and alkalosis, as I said before, the cause is always a flux in bicarb or hydrogen ion levels. Because see, if you look up here at the bicarb buffer system up here, say you have diarrhea, which diarrhea is one of the main reasons why you would lose your bicarbonate, too much bicarb at once. So this would be diarrhea, and you lose too much bicarb. So let's look up here. This goes down. So if this bicarb goes down, it's going to work backwards, and it's going to affect your carbonic acid amount because the ingredients won't be there. Your HCO3 isn't going to be there enough to make enough carbonic acid, and that's going to affect your levels of CO2. It's going to reduce your levels of CO2. So see how the levels of bicarb, if the levels of bicarb go down, it affects your levels of CO2 going down. And this is for metabolic. Remember your kidneys, your renal system. If your bicarb levels go up too much, or actually what would happen is, it's not that your bicarb levels would go up, it's that your hydrogen ions would go down too much. So by comparison, your bicarb levels would be too high. If your hydrogen ion levels go down, that would be if you are vomiting. Because if you're vomiting, you're emptying your stomach contents. What is the digestive acids in your stomach? Hydrochloric acid. So hydrochloric acid are the digestive juices in your stomach. So if you're throwing all of that up, you're getting rid of the acid, the hydrochloric acid, which means you're getting rid of your H levels. So that's going to go down if you're throwing up too much. So if this goes down, let's look up here at the formula. If this goes down, because you threw up all your hydrochloric acid, so your H levels, your acidic hydrogen proton levels go down. Since you don't have enough hydrogen ions in your system because you're throwing them all up, this is going to affect your ability to form carbonic acid, because that one of the H's in the carbonic acid is not going to be there because you don't have enough. So that's just going to end up leaving this all alone without its pair, without its H hydrogen pair. So that means when you get over here, your carbon dioxide levels are going to shoot up through the roof because there are no H's over here to tie to it in the carbonic acid system. Now let's look at this in a chart form. If you have, here's respiratory acidosis. Now what is the cause of respiratory acidosis or alkalosis? It's a flux in CO2 levels. So in respiratory acidosis, if your CO2 levels go up because you're not breathing it out enough, right here, your CO2 levels are going to go up, then you're going to end up making more carbonic acid because there's always water there. There's enough water there to make more carbonic acid with the increased CO2 levels. And if that happens, if your carbonic acid levels go up, then that's going to increase the amount of these, isn't it? Because there's more carbonic acid to split off into bicarb and your hydrogen ion. So down here in the chart, if your CO2 levels go up, then that means your bicarb level is going to go up and your hydrogen level is going to go up because of the excess of CO2. Now in respiratory alkalosis, for some reason you're hyperventilating and you're blowing out too much carbon dioxide. So now your carbon dioxide levels are bottoming out. Up here, if your carbon dioxide levels bottom out, then there isn't going to be enough to make carbonic acid. There isn't going to be enough CO2 to make carbonic acid. So that's going to limit the amount of bicarb and hydrogen ions made. So the bicarb's going to go down and your hydrogen levels are going to go down. Now let's do metabolic. In metabolic acidosis starts when, like let's say if you have diarrhea and you're getting rid of too much of your bicarb from diarrhea, your bicarb levels are going to go down. And that's the first cause of metabolic acidosis. You have diarrhea, your bicarb levels go down. So let's look at bicarb up here in the formula. If your bicarb levels go down, then there isn't going to be enough bicarb to make enough carbonic acid. So your carbonic acid levels are going to go down. And if your carbonic acid levels go down, then there isn't going to be enough to make carbon dioxide. And there's always water, so don't worry about the water. But there isn't going to be enough to make carbon dioxide. But look what we have over here. Look what's left over. If you don't have enough bicarb to make enough carbonic acid to make enough carbon dioxide, what's left over here is your hydrogen ions. And your hydrogen ions, they don't go down, they stay the way they are. So by comparison, your hydrogen levels actually go up by comparison because they don't have the bicarb to pair with to turn into the carbonic acid. So your hydrogen levels are going to go up. And of course, if you're, as I said before, if your bicarb levels go down for metabolic, then that creates a chain reaction backwards in the chemical formula, which means your carbon dioxide levels are going to go down as well. But those hydrogen ions are going to be left all alone to do damage. Those acid ions are going to be left all alone to do damage. So that amount is going to go up in comparison. So your metabolic alkalosis, that would be if you are throwing up. So if you're throwing up, what are you throwing up? You're throwing up hydrochloric acid from the contents in your stomach. So if you're throwing all of that stuff up, that means your H's are going to go down because you're throwing them all up. So you don't have them in your body anymore. Now, if your H's are going to go down, then you're not going to have enough acid to make enough carbonic acid. And if you can't make enough carbonic acid, what's going to happen? What's left over here? The bicarb over here is left to its own devices. So by comparison, if your acidic levels go down, if your H levels go down because you're throwing them up, you're leaving all of this bicarb in your system. So by comparison, the bicarb levels go up because there aren't any H's to pair with and make carbonic acid about. So down here, let's go, bicarb levels go up. This HCO3 is left unchecked. It doesn't have any acid to pair with. So it comes all the way over here, splits, and turns into water and carbon dioxide. So that means your carbon dioxide levels, what happens? They go up. So again, if you're throwing up and you throw up all your acid content, your H's, then the H's are nowhere to be found. So there's all this extra bicarb formula, this bicarb floating around, which ends up splitting and making HCO3 makes H2O and CO2. So those levels are going to go up. So let's put up on CO2. So once again, respiratory acidosis starts with an increase, is started by an increase in CO2 levels, which increases the bicarb levels, which increases the hydrogen proton or the hydrogen ion levels, and that's acid. In respiratory alkalosis, if your carbon dioxide levels go down, then your bicarbonate levels are going to go down, and therefore your hydrogen levels are going to go down, and that creates an alkaline situation. In metabolic acidosis, it starts with your bicarb. Your bicarb goes down. If your bicarb goes down, that means your hydrogen levels are going to go up because there's no bicarb to check it. And if your hydrogen levels go up and there's no bicarb to check it, then your carbon dioxide levels go down. In metabolic alkalosis, your bicarb levels go up, which soaks up all of the acid, soaks up all of the H ions, and which means there is an increase in your CO2 levels. So let's take another look at this chart for a minute. I cleaned it up here for you. If you look at this chart, if we're looking at, let's say we're looking at respiratory acidosis, the CO2 level goes up and the bicarb level goes up. In alkalosis, respiratory, the CO2 level goes down, the bicarb level goes down. In metabolic acidosis, the CO2 level goes down, the bicarb level goes down. In alkalosis, the bicarb level and the CO2 level both go up. So see, these two columns are going to be exactly the same. If one's up, the other one's up. If one's down, the other one's down. So we can actually just combine these into one column and one arrow instead of both of these because they're both going to be the same, right? So I have that here on the next page. Here we go. So now we have this combined, since it's going to be the same, the arrows are going to be pointing the same direction. Respiratory is going to be affected by the CO2 level, and metabolic is going to be affected by the bicarb level, but the arrows are all going in the same direction. Now that we can understand this, let's go back to what I first said. Say you're a nurse or a healthcare practitioner and a patient comes in and gets their blood taken. You are given their pH level, their carbon dioxide level, and their bicarb level, which again, these two are going to be the same. They're either going to both go up or they're both going to be down. But you're given the pH level. You're not given the hydrogen level, the hydrogen content level, and this is what defines if it's going to be acidic or alkaline, right? So we have to understand that pH and H levels are opposite from each other. So if the hydrogen ions are up, that means the pH is down, because lower pH is acidic, right? and high hydrogen level is acidic. If the hydrogen level is low, that's alkaline, which means the pH is going to be high. So over here for the pH, if the hydrogen level is going up, as in respiratory acidosis, the pH level is going to be down. In respiratory alkalosis, when the hydrogen level is down, the pH level is up. Metabolic acidosis, the hydrogen level is up because it's acid, which means the pH is down. And alkalosis, the hydrogen level is down, which means the pH level is up. Since we don't even test, you can't test a patient's blood for their H content. You test it for the pH content. So we don't even need to worry about this column anymore. What we're going to see in blood tests, we're going to see the pH level, and we're going to see this carbon dioxide and bicarb level. So now we have this cleaned up to just a 2-column table where if respiratory acidosis, the respiratory is going to be about the carbon dioxide, and the metabolic is going to be about the bicarbonate. So respiratory acidosis, the carbon dioxide level is going to be up and the pH is going to be down. In respiratory alkalosis, the carbon dioxide level is going to be down and the pH is going to be up. In metabolic acidosis, the bicarb level is going to be down and the pH level is going to be down. And the pH level is going to be down. In metabolic alkalosis, the bicarb level is going to be up and the pH is going to be up. So now let's take a closer look at this real quick, at this chart, because this is where it gets really easy to memorize all of this. You got to memorize all the information that I just told you in this video, but it's actually really simple to memorize. And how you memorize it is the word Rome. R-O-M-E. Respiratory opposite. Metabolic equal. So here's respiratory right here. Respiratory opposite. So you notice respiratory opposite. When one arrow is up, the other arrow is down. When one arrow is down, the other arrow is up. Metabolic equal. When one arrow is down, the other arrow is down. When one arrow is up, the other arrow is up. Now, how can you determine which one is acidosis and which one is alkalosis? Well, that's because of the pH. If pH is down, that's acid. So here's acid. Here's another place where the pH is down. Acid. So those are your two acids. Here's where the pH is up, so that's alkaline. And here is where the pH is up, that's alkaline. So all you need to do is determine, is the pH down or up, is it acid or alkaline, and then you look over to this column and see if these readings are the same or the opposite of your pH reading. So this one is going up while your pH is going down. That's opposite, so that must be respiratory. Over here on the second line, this is going up, so that's alkaline. Your pH is up, that's alkaline. But it's the opposite, the arrow is in the opposite direction as your CO2 level, so that's respiratory alkalosis. Now down here we determined that this is acid, this pH going down is acid, but look, the bicarb level is also going down. So since those are equal, they're both going down, it must be metabolic. And On here, on the last line, this pH is going up, which means alkaline. And look, your bicarb level is also going up. So that's equal. The arrows are both equally going up, so that must mean metabolic. Well, I hope that explains it. Feel free to ask any questions in the comments, and don't forget to like.